Okay, continuing on with the problem. So we made our sign chart. We found where things are increasing or decreasing. Now we are figuring out the local max or min. So we did the first one at 2 pi over 3. It changed from increasing to decreasing, so it had to be a local maximum. And then we found the y coordinate by plugging into the original function, and we got a y coordinate of 5/4. Going on with the next guy. So moving on to x equal pi. We have a local max, no, local min, excuse me, at x equal pi. We had to have a minimum. At x equal pi, there's a local minimum at x equal pi with y equal f of pi. Y coordinates are always the original function. So plugging into the original, that's going to be sine of pi squared minus cosine of pi, which should be 0 squared minus -1, or 1. So the point pi 1 is a local min. Then we got one more number, 4 pi over 3. So we've got a local, and at 4 pi over 3, the derivative changed from increasing to decreasing, or the function, or the derivative changed from positive to negative, or the function changed from increasing to decreasing. That means we had to have a local max. And so we have a local max at x equal 4 pi over 3 with y equal f of 4 pi over 3, always the original function. Y coordinates always come from the original function, so I'm going to have sine of 4 pi over 3 squared minus cosine of 4 pi over 3. Sine of 4 pi over 3 is negative square root of 3 over 2. Cosine of 4 pi over 3 is negative 1/2. So I've got 3/4 plus 1/2 for 5/4 again. And so I have the point 4 pi over 3 5/4 is a local maximum. Now the last thing that we're going to do, and then we're going to look at a picture. The last thing we're going to do is, and I did warn people here about this, it said, which, if any, of the extreme values are absolute? In the homework explicitly looking at the endpoints. So just checking the endpoints. So for my endpoints, at x equals 0, y is going to be f of 0. So sine of 0 squared minus cosine of 0. So that's going to be 0 minus 1 for negative 1. So I have 0, negative 1. And at x equal 2 pi, we're going to have y equals f of 2 pi, which would be sine of 2 pi quantity squared minus cosine of 2 pi, which again is still going to be 0 minus 1 or negative 1. So I have the point 0, negative 1. So as far as absolute maxes or mins, absolute max is going to be the 5/4. That I got y values of 5/4 and 5/4 there. So this is a local max and an absolute max. Same thing here, local max and an absolute max. We'll write it above because I'm running out of room here. Because those were the biggest y values I got. I got y values of 5/4, 1, 5/4, negative 1. So my 5/4 were the absolute max, And my absolute mins were these negative ones here. And so these guys, both of these, are an absolute min. And so there we answered the question. Now we're going to hope that my calculator has enough juice in it to actually check the problem. So I'm going to put the original problem in here. So I put my original function in there, the original, and now I'm going to graph it. Now I'm not going to hit zoom 6. I know all sorts of stuff about this function. So I'm going to press window. And they told me to graph it from 0 to 2 pi. So I'm going to put in 0 to 2 pi. Then look at my chart. 2 pi over 3 pi, 4 pi over 3. Pi is the same thing as 3 pi over 3. So instead of counting by ones, it's going to be logical to count by pi over 3. That will pick up all those important numbers there. So for x scale, I'm going to do pi divided by 3. Because that picks up every value there. It's going to pick up 2 pi over 3. It's going to pick up pi. It's going to pick up 4 pi over 3. Then for the y's, I have a minimum value, absolute minimum value of -1. I'm going to go a little bit further. I'm going to go -1.5. And I had an absolute maximum value of 5/4. I'm going to go a little bit bigger. I'm going to go 2. And I'll let that count it off by ones. And after I've set an appropriate window, and that's part of the point here, that the calculus gave us the numbers to make my machine work well. Yes, most of us have graphing calculators, and why can't I just always put it in there and press some sort of button? You can put it in there, but to make the machine work well, we need the numbers that I calculated here. So I put in the appropriate numbers, I press graph, and we hope that it matches what we found. We found that the function should increase, decrease, increase, decrease. Increase, decrease, increase, decrease. Increase, decrease, increase, decrease. It matches that. Increase, decrease, increase, decrease. It absolutely matches what we said about increasing, decreasing. We said that we had absolute maximums and local maximums at 2 pi over 3, 5/4. So trace 2 pi divided by 3. We said that that should be both a local and absolute maximum. So I put that number in, did trace, put that number in there, hit enter. It goes to that point, and it, honest to goodness, tells me, yep, that's a local max, and not only does it look like a local max, it gives me the correct y coordinate, 5/4. We said that there was a local minimum at pi, so trace, well, I already pressed trace, just put in pi. I didn't put in pi. Put in pi. Hit enter, and it goes to pi 1, which is exactly what we said, that there'd be a local minimum. Then we said at 4 pi over 3, so 4 pi divided by 3 goes to it. Yep, that's a local max, also an absolute max, and the y coordinate is 1.25. And then we said that we should have 0, -1, 2 pi -1, those check. Everything absolutely checks, so you know your answer in this case is perfect. That these, we're talking about graphs. And so they will absolutely check if you give the machine the right information. Here we gave the machine the right information. Notice the picture you'd get if you just press the standard window. And there's the answer you get on the standard window, which is not what they wanted from us. They wanted to know what was going on to 0 to 2 pi, and that machine's not giving you that information. It was only because we gave it this number, these numbers, that we could make the machine do this problem. And that is the end of this problem. So we got 5 minutes left in this video, so we'll go ahead and get started on the next problem. Okay, find the local extrema, the open intervals in which the function is increasing, decreasing, the intervals in which the function is decreasing. So same thing, we're going to do those steps. Now you can make your life harder if you want, or you can make your life easier. This is a product. I can simplify this first. Multiply out. And recall x to the a times x to the b is x to the a plus b. Then I'm going to add my exponents. So I'll zoom in for a little bit. That's a little bit more legible. So I'm just going to distribute here. And so I'm going to have f of x equals 2/3 plus 2 is 8/3. So I have x to the 8/3 minus 4x to the 2/3. That is still the original. But I do not need a product rule on it anymore. 1, find the derivative. So that's going to be 8/3 x, multiply by the exponent, decrease the exponent by 1, 8/3 minus 1 is 5/3. So where that 5/3 came from, that's 8/3 minus 1. Then the 4 hangs out, multiply by the exponent, decrease the exponent by 1. And let's just make that look a little prettier. So that's 8x to the 5/3 over 3 minus 8 over 3x to the 1/3. And there's my derivative. Check your derivative twice, because if your derivative's wrong, everything else is going to be wrong. Okay, critical numbers. Set the derivative equal to 0. Clear the fractions. Equations with fractions, clear the fractions. So I multiply everybody by 3x to the 1/3. Over here, the 3's cancel. And so I'm going to get 8 to the 6/3. Add the exponents. 5/3 plus 1/3, 6/3. So where that came from, 5/3 plus 1/3 is 6/3. And yes, I'll call that 2 on the next go around. Over here, everybody cancels. So I get minus 8 equals 0. So that's 8x squared minus 8 equals 0. 8x squared equals 8. X squared equals 1. X equals plus or minus 1. Take the square root of both sides. Do not forget the plus or minus 1. Then also do not forget where the derivative doesn't exist. My derivative involves a fraction. And so there's potential for this derivative not existing. And so I look at the denominator that has an exponent in it, or not an exponent, an x in it, set that equal to 0. Cube both sides. And I get x equals 0. So I get 3 critical numbers, plus and minus 1, and 0. And 0 is an honest to goodness critical number because it is in the domain of the function. I can plug 0 into that function and it's going to work just fine. So 3 critical numbers, plus and minus 1, 0. And we'll finish this problem on the next video.